2.2 rules for differentiation. So the first rule is that the derivative of a constant is 0. C is a constant, and we call this rule the constant rule. The constant rule. Number 2, the derivative of a power function x to the n is n x to the power n minus 1. So n is a real number, and we call this the power rule. So basically the power goes on the front and the power becomes 1 less. Let's have examples with these two rules. So if my function is a constant, we're going to use different notations for the derivative. dy dx, or the derivative, is 0. That's rule number 1. B, if f of x is 0, again constant function, different notation, f prime of x is 0. That means the slope of the tangent line at that point is 0. And at any point, since the function is a constant. If y equals 2, again, this is a constant function, y prime is 0. G of t is negative 3 over 2, again a constant, then g prime of t is again 0. Now example with rule number 2, if f of x is a power function, x to the third, the derivative, according to our rule, here's the rule, the power rule. So the power goes on the front, 3x, 1 less than the given power, 3x squared. So this is the rule. B, if y equals 1 over x squared, the way it's written doesn't look like a power function, but we can write it as x to the negative 2. So here is a formula we're going to use a lot. If I have x to the negative n, if I have a negative power, that is 1 over x to the n. And now if I have negative power on the denominator, becomes positive on the numerator. But this is what we needed to use here. That's why 1 over x squared is x to the negative 2. And here y prime, the derivative, is negative 2x to the negative 2 minus 1. So it's negative 2x to the power negative 3, which is equal to negative 2 over x to the third. We're using the same formula for the negative exponent. So C, g of t, is equal to t, linear function. The derivative is just 1, because the coefficient in front of it is 1, the power is 1, t to the 1 power, 1 goes on the front. Or you can think about, let's look at this graphically. Y equals t is a linear function, and the slope is 1, right? So slope is equal to 1. If you think about y equals mx plus b, m is the slope in front of x. So another example, find the slopes of the graph. Find the slopes of the graph f of x equals x squared at x equals negative 2, negative 1, and 0. Now that we have a formula, the derivative is the same as the slope of the tangent line. That will be 2x according to our formula number 2. So at the point x equals negative 2, the slope, which is the same as the derivative, f prime at negative 2, would be 2 times negative 2, or negative 4. At the point x equals negative 1, the slope will be the derivative at negative 1, which is 2 times negative 1, negative 2. And at the point x equals 0, m is equal to f prime at 0, which is equal to 2 times 0 equals to 0. Let's illustrate this with the graph. Since we know the graph of our function y equals x squared. So we had the point negative 2. So that point is, I need more room here. Let's see. Let's illustrate that at negative 1. That would be easy at this point. The tangent line right here. So at that point, negative 1, just negative 1, 1. At this point, the slope is negative 2. And then at the point 0, at this point, we found the slope is 0. And indeed, here is the slope 0, horizontal line. So rule number 3. Rule number 3. Let's go back and name rule number 1. Number 2. And so rule number 3, d dx of a constant times the function is equal to that constant can go on the front, and then the derivative of the function. C is a constant. See, if I have a constant in front of my function, it can go on the front. We call this constant multiple rule. Constant multiple rule. So example, A, if y is equal to 2x to the 1/2, we have this constant 2 in front of our function. So y prime is equal to that constant times the derivative of x to the 1/2. We are using the power rule. So 1/2, x to the 1/2 minus 1, negative 1/2. So that is x to the negative 1/2. We're using the same rule with the negative exponent. So 1 over x to the 1/2, which is 1 over square root of x. B, f of t equals to 4t squared over 5. So now we're going to separate the constant 4/5 from our function. So when we find the derivative f prime of t, keep the constant on the front, then use the power rule. 2 goes on the front, t to the power 1. So that's 8/5 t. This is the derivative, 8/5 t. C, example C, y equals negative 3x over 2. Let's separate that constant. And so now y prime would be negative 3 over 2. The derivative of x is 1. Derivative of x is 1. So I'm just going to write down here 1. Negative 3 over 2. It makes sense. The slope of the line negative 3/2 x is negative 3/2. Example D, y equals 3 pi x. Recall the pi is a constant, so we keep the constant 3 pi, and we know the derivative of x is 1, so just 3 pi. Example E, y equals negative x over 2. Let's separate the constant, and so y prime will be just negative 1/2 times 1, because the derivative of x is 1, just negative 1/2. Another example, A, y equals 5 over 2x to the power 3. Before we find the derivative here, we need to simplify. So we have 5 over 2 to the third is 8, x to the third. Let's separate the constant. And so I'm going to write this x to the third as x to the power negative 3. Again, our rule for the negative exponents applies here, so it looks like a power function. So y prime will be 5/8, the constant, times the derivative of x to the negative 3, which is negative 3, x to a power negative 3 minus 1, which is negative 4. So it's negative 15 over 8 x to the negative 4. And if you want to write it with positive exponent, then x to the 4th becomes denominator. Okay, so example B, y equals square root of x. That doesn't look like a power function, but we can write it as x to the 1/2. That's one of our formulas from algebra. So y prime is 1/2 x to the power 1/2 minus 1. So 1/2 x to a power negative 1/2. So we have a negative power. That's going to go on the denominator. And we also know x to the 1/2 is square root of x. So we just simplify it. Example C, y equals 1/2 cube root of x squared. That's equal to 1/2 x to the 2/3. Let's separate the constant, which is 1/2, and write x to the negative 2/3 here. Y prime would equal to the constant, keep the constant 1/2, and then do the power rule. So negative 2/3, x to the power negative 2/3 minus 1. So we cancel the 2's, and we have negative 1/3, x to the negative 5/3. So that is negative 1 over x. We're going to have 3 first. X to the 5/3. And I'm going to leave it like this. Now what we use here, we use the formula from algebra that says x to the power m over n is equal to nth root of x to the m. So this is the formula from algebra we use whenever we have a fractional exponent, or if we have a radical to write it as a fractional exponent. Rule number 4. If I have a derivative of a sum or difference of two functions, and I need more room here, so I'm going to write this again. So this rule is called sum difference. In other words, if I have a derivative of f of x plus or minus g of x, so we can do plus or minus, and that's the derivative of f plus minus the derivative of g. So very straightforward. Example. We use this a lot with polynomials. So here's a polynomial, and we want to find the derivative. We're just going to use the power rules and the constant multiple rule. So derivative of x to the third is 3x squared. Keep the constant 4, and then derivative of x squared is 2x. So 3x squared plus 8x, and that's it. Part B, y equals 3x squared minus x plus 1 over x. Now, this is not a power function, and we don't have a rule for quotient, so we need to be very careful to simplify our function, divide everything by x, and then simplify. So if we cancel the x, then it's just 3x minus 1 plus 1 over x, which is 3x minus 1 plus x to the power negative 1. Again, we're using those fractional exponents here, so we write everything like a power function. Now we find the derivative y prime is equal to 3. The derivative of 3x is 3. The derivative of a constant is 0. And then we're using the power rule here. Negative 1 goes on the front, x to the power negative 2. So 3 minus 1 over x squared. And we can leave it like this. Last example, find equation of the tangent line. So far we've been finding the slope, but now we're going to go further and find the equation of the tangent line to the graph of g of x equals negative 1/2 x to the 4th plus 3x to the 3rd minus 2x at the point negative 1, negative 3 over 2. So we have some polynomial graph, it's continuous, and we want to find the equation of the tangent at that given point. We know that the slope of the tangent line is the derivative. So we don't have to use that limit definition, we're going to use a power rule. So negative 1/2 is a constant. We keep it, derivative of x to the 4th is 4x to the 3rd. keep the 3 as a constant. Derivative of x to the third is 3x squared and minus 2. So we simplify. This is going to be negative 2x to the third plus 9x squared minus 2. So this is the derivative as a function. This is f prime of x. To find the particular slope that we want, and that is the derivative at the given point, negative 1. So substitute negative 1 for x. And we have this slope equals to 9. So now we have slope equals to 9. We have a given point, negative 1, negative 3 over 2. We need to write equation of a line. So we have from algebra, point slope form. So if we have a given point and a slope, the equation of the line is y minus y1 equals mx minus x1. So we have the slope and we have the point. So the point is x1, y1. We substitute and we have y plus 3 over 2 equals 9x plus 1. We're going to simplify this. Distribute. Subtract 3 over 2, 9x plus 9 minus 3 over 2, y equals 9x plus 15 over 2. So this is the equation of the tangent line. And this concludes the video.